Okay, today I have my power supply, my 48 volt power supply, and I need to switch out this 36 volt power supply. Right now I currently have a 420 ounce NEMA 23 stepper motor on my Z-axis, and I purchased the 570 ounce, which matches my other motors. My previous connections, I use these plugs for the motors. I just cut this one off because all of my other ones are soldered on, and I'm going to do the same with this Z-axis. You got each wire is soldered, and then I have the heat shrink, and then I use this to protect the wire. I just pulled it off to show the heat shrink. And you cut the wires at different sizes, so all of the connections are staggered. So on this, the white wire is long, and then on here, the white in this case will be the red, so that's long. The next one is the black, so they're actually, yeah, the black. So then you got the black and the green, and then the blue. For the motor connections, black is A plus, green A minus, red to B plus, blue to B minus. On my wiring, I only have black, green, red, and white. So the white is going to make up for the blue, and you can see. So I'm going to go ahead and take this out and do some soldering. Okay, I got the new power supply in. There's the old one. I had to drill and tap a new hole. This one here was smaller, so I screwed it to an aluminum plate, and that's what I had it bolted in there with, or screwed in there with. Just your line in, and I'm only using the one positive and negative off of this supply here. So I just switched the wires, and I reset my dip switches because the other one was 36 volt, this one's 48 volt in a different amperage, and that's the settings for this one for the 4.9 amp, and I have it set on 10 microsteps, and those are the dip switches. All of these drivers have your settings on the side there. You can't really see them that well, but there's all of your switch settings. And I got the old motor off, and next to the new motor, you can see the new motor's a little bit bigger. I'm going to go ahead and solder these wires onto here. Put the heat shrink on them. So what I'll do is I'll just pause this, solder some wires, and then I'll start again. Okay, simple to solder. I'm just using a battery operated soldering iron. I love this thing. This thing works great. You know, some rosin core. And what I do is I slide some heat shrink up onto the wire. All of these wires are cut at different sizes, so once they're soldered, then you can slide your solder, or slide your heat shrink over your solder joints. It's kind of hard to do this with one hand. And then I just use a little torch to shrink the heat shrink. Let me get this red wire and then I'll finish the rest and then I'll slide it down. Okay, I got all my wires soldered together with the heat shrink. Motor's bolted back up. And I normally draw a red line or a line on there to make sure that nothing gets loose, or if it ever does get loose and then marks don't line up, I know that there's something wrong right there. I have everything powered up. And I do gotta shorten that wire up, but I'm not worried about that right now. And I think instead of just running the Z-axis off of the one power supply, I'm going to run the Z and the X off of the one, and then the two Y-axis motors off of the other. I have it set up. I didn't have to change any of my steps or any of that, but I have it set up with a dial indicator, and I have it set up for 100 thou. So if I go down, up, down, down, up, 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 down, down, down. So it's right on the money. Go into my configuration. The steps per inch, the two Y-axis are the same naturally. The X and the Z is different because of the setup. My velocities, to probably up my velocity to a higher number and acceleration now that I have the bigger motor on there. That's it. It's working good. If you're building these tables, it's really good to invest in, heat shrink kit like this, because it definitely comes in handy. A torch to shrink the heat shrink. Soldering iron is a must. Originally I went with these plugs and these 3D printed caps that they never really fit good on these. I think these are 60 millimeter motor frames. They're bigger than the normal NEMA 23. I think the normal 23 frame size is usually 50 or 55, and these are 60, so these caps really never fit that correctly. And that's the reason why the screws are up like that. I liked the look of them because it was a cleaner look. You kept all the wires out of the way. But what I've done is, the first thing I do on the motor is I put heat shrink on the wires. And the heat shrink comes down to here. So you got about 4 inches of heat shrink. And then my connections are, over here. And this way, if you ever have to remove the motor, you have plenty of wire to work with. My Z-axis is pretty heavy. I have 20 millimeter linear rails on there, which are extremely heavy. Plus I have the Scribe that I built All of this setup here I built myself. I mean, the whole Z-axis I pretty much built. I have all my solenoids on here, my motor, the air regulator. You know, so that adds a considerable amount of weight to this. So that's why I think I was losing steps on this smaller 420 ounce motor. My slide for my scribe here, that's a steel plate, so it's heavy. You know, 1/2 inch aluminum plate, that stuff adds up. It definitely adds up. My linear rails on my gantry here are the 15 millimeter, and I had started to build a new Z-axis, a smaller one, because I don't think it needs to be this big, and that's 15 millimeter. My other Z-axis that I'm working on is here, and this stuff is time consuming also. That's my 15 millimeter rails on the Z-axis. And there's a considerable difference in size. I don't want to lose my bearings on here, so it's kind of hard to set it up. But there's a big difference in size and weight, you know, from that to that. But I have everything set up, everything works good, so I'm gonna do some cutting on this tomorrow.